Now entering the Bitcoin Podcast Network.
Welcome to Hashing It Out, a podcast where we talk to the tech innovators behind blockchain infrastructure and decentralized networks. We dive into the weeds to get at why and how people build this technology and the problems they face along the way. Come listen and learn from the best in the business so you can join their ranks. All right, we're back. Episode 31 of Hashing It Out. As always, I'm here with Colin Couchet. Say hello, Colin.
Hello, Colin.
Nice. You're getting better at reproducing what I say. I'm going to start making it more difficult from here on out, so you have to really get into it.
You have to do funny voices, man. Do you do any?
I do a lot of funny voices, but I need to be a little drunk to do them, and the time is not good to be drunk today. So.
Yeah, we recorded drunk ones before, but... It's been at like 7 o'clock at least, yeah.
So today's episode, we're here with Michael and Luis from the Pokt Network. Say what's up, guys.
Hey, Corey. Thanks for having us on.
Hello. Thank you for having us.
Yeah, of course. And I'm curious to see, I have a lot of questions about how Pokt Network works, but to get started, why don't we get an introduction as to who you are, how you got in the space, and what the Pokt Network is from like a 10,000 feet overview.
Sure. So I'm Michael, and I got into Bitcoin in 2013, up to that first run-up, and got super interested into it then. And I'm also an iOS developer, so I've been an iOS developer for about 4 years professionally. And when we started working on Pokt about 3 years ago, or 2.5 years ago, I really got into smart contract development on Ethereum. And because me and Luis, we had met at a previous startup. And been really deep into Ethereum since then. And now we're building our own protocol.
Great. Luis, you want to do the same thing?
Sure. As Michael pointed out, I've been doing software development for a bit longer, but I didn't get that much into crypto until around the same time we started developing the project. I was aware of the technology and the implications, but I never dove deep until those first conversations. So from that point on, it's been a whole run into building and speccing out this whole project.
So that's interesting. There's a lot of developers who are getting into the space. What was your background before you did this, and what was your barrier to entry?
Yeah, so basically I was more of an product-oriented developer. I focused on end-to-end, from business idea to actual execution kind of projects. So that led me to do a lot of startup work. And then I got aware of the technology, not because of the whole price thing and people getting rich, but rather about the profound implications that it will have on security and things like user authentication, decentralized user authentication and all that. So that really piqued my interest from a systems and architecture point of view. But it didn't, I didn't get to the point because the tooling and getting into it was so cumbersome. So by the time we started talking about Pokt and the initial idea, I started to see an improvement. Ethereum was picking up. It was easier to get into, for example, smart contract development and all that. And all those things allow you to have a bigger design space and headspace into what the technology is about.
So I see Pokt as almost providing services at layer 0. Can you give an introduction to what the point of Pokt is and what problem you're trying to solve?
Yeah, I would say that Pokt is like a decentralized Infura, really. So what it does is incentivize people to run a full node, put a thin API layer on top, and what the protocol does is route API requests from a client to the right node for the right job. and there's a randomly selected committee of validator nodes that validate those API requests. And once those API requests get validated, the people serving them get paid or in Pokt. So the protocol, it's an inflationary protocol, and it mints tokens to those providing the work. Another way we like to explain it is like almost like AWS. How AWS, if you have an app like Slack, for example, and every app needs storage and compute, for example, right? And AWS acts as a layer in between the actual application and those core functions that are needed to build those applications. If I'm a blockchain developer and I want to build something using Bitcoin, or I want to build something with anonymity using Zcash or Monero, or I need file storage, I need to be able to talk to that blockchain. So with Pokt is a infrastructure layer that sits in between the developer and the actual blockchain they want to communicate to. And in the end, what it does is incentivize people to run those full nodes and service those API requests.
Now, does this only work for Ethereum?
No, Pokt is blockchain agnostic. So we built Pokt really modular, and we've got basically it's a plugin system that we've built. And these plugins, correct me if I'm wrong, Luis, but they're around 150 lines of code. And right now, as long as you have a JavaScript library that we can work with, it's very easy for us to spin up these plugins. So the idea is, we think that we're going to live in a world with many dozens, hundreds, or even thousands of blockchains, governing our lives. And for the many blockchains that are coming out in testnet today, and the many that haven't been invented, we think it'll be much, much easier for them to build out a plugin really simply through the Pokt network that just basically abides to our interface. And all of a sudden, you've got a network of hundreds of thousands of nodes willing to spin up your infrastructure as long as there's developer demand. So we're really trying to make it really, really easy for new blockchains coming out and blockchains developers to actually build those applications.
So you're trying to provide the service for people to say, all right, I want to have, like say I'm creating a dApp, I want to have this type of functionality. Okay, that requires this blockchain. I'll then call that appropriate API to the Pokt network to get that information securely, so on and so forth.
Exactly.
Okay.
Exactly.
So this is somewhat of I'm seeing of a recurring narrative right now, at least in the lower technical space, is this network layer and how it's actually done, and it's quite difficult. You're seeing a lot of the conversations in Ethereum around moving from dev P2P to lib P2P, like how you're actually making peer connections and maintaining those connections, especially when the type of node they're using may have a lot of churn, which means that like it comes on the network, off the network. So like you're not really sure on the availability of all the nodes that you have. Like how are you addressing this? Like what are you building on? Did you create your own? Does that even matter for what you do?
So currently, sorry about that. Currently, our current architecture design doesn't really care too much about that. We established a protocol for liveness, so there will be a set of nodes providing liveness checks between their peers, where their peers could get penalized economically speaking if they fail these liveness tests. So in our particular case, we're also trying to achieve networking modularity in the sense that we want people to connect to nodes in whatever network protocol they want to reach them. Right now, we're focusing a lot on HTTP and WebSockets because those are the most popular. But we want to allow nodes to connect between themselves using whatever kind of networking layer they choose to.
So could we get a little more into the liveness tests that you're talking about? What does that mean to test for liveness?
So we have two basic requirements, right? If you're up and the speed at which you respond. So we haven't put the actual numbers there yet, but we have the framework for it. We're gonna do a sequence of steps every X amount of time, and if you fail those steps to respond, first respond, and second respond within a certain time frame, then you're gonna be under the subject of you failed this liveness check. And what the protocol establishes is we want nodes to always maintain reliability and availability of their service at all times. But that's not always the case with the peer-to-peer networks. Nodes can come in, join, and leave at whatever time they want. So what we want to do is establish a protocol to let them join and leave whenever they want, but at the same time, whenever they're present, they need to be alive during that period.
Okay, so let me try and get this like a standard user story here. Someone using the Pocket network. I have node infrastructure, and I run various nodes for whatever services that I do already, and I use the standard node infrastructure that those networks provide, and then I interface that with the Pocket network layer that sits on top of it, and I say I'm running these nodes. I would like to broadcast these services within the Pocket networks that I'm going to serve this information to the Pocket network. And then I basically get checked by the Pocket network to make sure that those nodes are running and I can serve that information appropriately. And I also stake Pocket, which we'll get into a little bit, which then kind of guarantees and also penalizes based on those liveness checks you just said. And then I get paid for serving information to DApp. So on the DApp layer, all they would have to do ostensibly is say, I want to connect to these blockchains, Pocket network, make that happen for me.
Correct. So I actually want to bring up a conversation you had with Alex Van Nisad you had a few weeks ago, and you're talking a lot about making it as easy as possible for developers to access blockchains with UX and UI. I know Alex's space is focusing on a bunch of the UI, UX for the user, but I would say that Pocket is actually focusing on the UX for developers. So we've got a suite of SDKs, for example, that we've built that make it really easy for a developer to communicate to those Pocket nodes. And basically, we've abstracted all blockchain queries and transactions to just two things, queries and transactions, right? So the plugins that we build or that anyone else builds basically conform to that abstraction and allows it to communicate easily to the Pocket node that the person is running, that someone else is running.
Okay. And have you learned, changed, know about some of the competitors that are doing something similar? Like I see DApp node as being somewhat similar to this type of service.
Yeah, DApp node. You've got Quick node. You've got there's a couple other ones I'm missing.
There's a lot of people that are trying to decentralize Infura right now because that's clearly a problem within the Ethereum ecosystem. But I guess what you're doing is trying to make it more broad than that. So you're not only serving Ethereum information, you're serving arbitrary information. And what's interesting about Ethereum, like if you think about just Infura and the sheer amount of volume of transaction requests that they get, generalizing that to other networks seems like a lot of work, or at least like a lot of bandwidth for a network to uphold. That's a lot of different things in one question. But what do you think about that?
Yeah. Sort of the first part, you're basically Pocket is here to basically incentivize someone to run a full node, right? So, Luis, if you want to talk to the bandwidth a little bit, but we think that this is kind of like a core layer for blockchains that are going to. Not everyone has an Infura,
yeah.
Right? In fact, Ethereum is the only protocol that has an Infura, and we consider Pocket as more of a application-specific blockchain meant specifically for people who are running full nodes with these thin APIs on top.
Yeah, and if I might address the bandwidth issue, not all the transaction data goes through the Pocket blockchain because that will induce a bottleneck by design. What is actually happening is that the small coordination layer on which Pocket node fulfills your request is what we're trying to achieve in our coordination, in the protocol coordination layer. So after that, the connection happens seamlessly between the client and the node, what we call a service node, the actual node that is fulfilling the API request. At a later stage, after that API request is fulfilled, the node will report to a set of randomly chosen validators the work that it's done. So after that work is approved, they're gonna get the reward.
Okay. That
So
makes more sense.
a lot of the work happens off chain, and originally Pocket was actually a set of smart contracts on Ethereum, but if you look at, for example, Infura scale, they're doing over 10 billion API requests a day now. Even batching that up and submitting that to a smart contract gets really expensive really fast. So part of our solution actually was to just build out a completely separate blockchain that incredibly decreases the cost of running this.
So when you say you're communicating with other blockchains, how do you commit to them? If you're like, what do the commits look like? Like, what if you're not doing what Infura does and batching things up and sending it and making it still pretty expensive? What are you doing instead to resolve these requests?
Okay, so that's a very interesting question. So as Michael pointed out, we have both an off-chain component and an on-chain component. So how do we maintain security across all those layers? So basically we have this sort of shard that is called a session. And a session is basically the connection between a client application, a set of service nodes, and a set of validator nodes. So during a small time frame, and we're trying to reduce that time frame as much as we can to avoid collusion. During a small time frame, the client is going to use that set of service nodes for them to fulfill the actual API request, and that happens off-chain. The client signs every request saying, hey, I want this data, and I'm signing that I am who I'm saying I am with this private key. And then on the service node side, they sign the response to that request. So now you have a set of signatures that prove that the client actually submitted that request and the service node actually fulfilled it. After the request is actually served at a later stage, the service node takes the request he's done and all the signatures and sends it up to the validators. And the validators confirm first the identity of both by doing a zero knowledge proof, which is something very standard by now, using the signature and knowing, hey, this is the client that this is who requested and this is who responded. And based on that set of data, we have two main interactions. We have queries, which we represent by allowing a set of metadata of at which block and on which state did the node read the data from. So that way the validators can go into their own copies of the blockchain and check that same state directory, if you may, and check if the data correlates. For transactions, it's way simpler, and you only need the transaction hash. And you use the transaction hash, you check the transaction information both ways, and then you just need to hit approve or deny. The validators get into consensus off-chain by signing, doing a transaction signature chain, and then that becomes a batch of transactions that goes into the actual Pocket blockchain. So that way we don't have to record into our own blockchain every single transaction, because that will be too expensive to do anyways. So what we do is we defer to these validators to actually batch these transactions off-chain and then submit them to the blockchain. Of course, everyone involved is staked. So if someone misbehaves or tries to collude, they get significantly slashed. And that's where the crypto economic model helps keep the incentives aligned.
So help me out here, because I see I might have missed something here. So that explains how you're kind of batching it to your layer one solution, the Pocket blockchain. But let's just say I'm trying to write a decentralized application on top of Bitcoin. And I have one Bitcoin in my wallet, and I'm trying to send, I don't know, half of it to somebody else. And in the meantime, while you're doing your work, I actually send, 0.75 Bitcoin to somebody else. And now I don't have the funds to support that transaction. Like, how are you resolving these sort of like the cross communication between the resolution layer on the actual blockchain and your layer one solution? That's what I'm not sure I'm quite grasping yet.
So the layer one solution doesn't actually care about the other blockchains, to be honest. The layer one solution only cares that the validators got into consensus, and that's proven by all the validator signatures and the transaction batch data. The layer one solution doesn't know what is Bitcoin, what is Ethereum, what is what. They only care about which client requested which data and which service node provided it, and which validators actually did the validation. The ones who validate all that are the service nodes at the stage of when you submit the transaction, and the validators when they actually validate the work that was done. So let me rephrase that in 3 steps. The client needs to submit the right request. And remember, every blockchain has protections for things like this, like replay attacks and all that. If I try to submit a second transaction, it's going to have a different nonce. So me as a client, I have no incentive to go ahead and do that, right? So in that particular case, it won't matter. In the second step, the service node is actually economically incentivized to check the transaction formatting and data before submitting it to the actual blockchain, because if they fail, they need to report that they failed to submit that transaction, and they get less money. So they're economically incentivized to check for transaction format. And then the validators are the last layer of defense, and they'll check that both the client submitted the appropriate request and that the service node respond in the correct manner.
Okay, so I see this as a service provider coordinator, and then a kind of a post methodology for incentivizing that coordination once it's been done. Is that a good way to sum up what's going on here? So like if trying to picture this, I'd say a good portion of our audience is Ethereum people. If you think about how MetaMask automatically connects to Infura basically on a default thing, but you have the option to change your provider. What this potentially could do is basically change that entire thing to just, go to the Pokt network, and the Pokt network sorts out who you get connected to.
Exactly.
And then that's more generalized because it's more than Ethereum. It could be any other network, IPFS, Bitcoin, et cetera, et cetera, et cetera. Right?
Correct, because there's a couple things I want to add. A Pokt node could be running the top 20 cryptos in the world, right? Let's say by throughput. And so one person is running those top 20 nodes, but then you've got an entire network of people running those top 20 nodes. And on the other side of that, for a developer, whereas granted, Infura is free, but other services like BlockCypher, BlockDaemon, things like that aren't free. Instead of a developer paying a fee to the network like you would normally, you actually would buy our token and stake it into the network. So as a developer, it'd be like a one-time transaction, and you would stake our tokens into the network. And what the network does is throttle your throughput, so the amount that you can access the network via API requests based on how much you've staked.
And that's a way to do like spam protection, I imagine. Or like,
yes, that's correct. In one layer, because the first layer, remember, it's always what we call the relay layer, the layer where the actual service goes through. There's also, it's an actual blockchain that is providing the finality guarantees, and it will work pretty much like any other blockchain. It will have its own JSON RPC interface. It will have you can send raw transactions, but we won't be hosting, for example, a smart contract platform or any other general blockchain things. We will only need what is extremely necessary to actually provide this coordination, this service coordination that you just described.
Can we dig a little deeper into what the Pokt blockchain is and how it works? Some of the details behind it.
Of course. So the Pokt blockchain is the lowest layer on the whole Pokt network system. So what the Pokt blockchain does is provide finality guarantees by having a set, it's going to be a proof of stake chain that is going to have its own set of validators, and you're going to be able to propagate transactions to it either through a relay, through a Pokt node, or you can just run your own and submit transactions to it. And what that will do is it will of course keep the decentralized ledger of everyone's balances. It will host the ledgers of the stakes of everyone. It will host a little bit of metadata with every stake just to know enough about each node staking or each developer staking, so that the coordination can actually happen. From that information, the other layers of the Pokt system, which are the session layer and the client, the service, and the session layers will use that data as the source of truth, basically. So we're using the blockchain as you will use any database in a normal system. If you think a normal web stack, you have a front end, you have a middleware, you have a database. So what we're doing is we're taking that and converting it to a version that works for us by saying, okay, we have a client layer, which is basically the interface that end users are going to use. You have a service layer, which is the one executing the actual transactions to the different blockchains. You have a session layer that the validators will use to actually validate all that work. And then you have the blockchain layer, which provides the finality of all the work that happened off-chain.
And I would assume the people who are running the nodes and also the Pokt network nodes, like just by interfacing with the Pokt network, you basically run a Pokt network node as well. And by running a node, are you automatically a validator? How does that work?
So it's very opt-in. Our client Pokt Core is going to allow you to do all at once in a single instance. Just like in Geth, for example, you can disable the JSON RPC, you can disable different modules just to suit your needs. The Pokt Core client is going to allow you to do all that. So what we envision is more of a service of how an architectural piece in an infrastructure machine will work, where you will want some instances of the blockchain running in a set of subnetworks. You will want your load balanced relayers, and you will want all your security measures in place to protect your nodes from outside attacks and whatnot. So in summary, what I'm trying to say is that you can pick and choose which actor you want to be in the network. You can be a blockchain validator and just participate in the proof of stake consensus that is keeping the finality guarantees of the blockchain afloat. Or you can participate in the relays and mint POKT tokens whenever you do work for the network. Or you can participate as a validator after passing a set of requirements and validate transactions for other nodes.
I'm seeing something I'm curious about now. Running a bunch of nodes across various networks is computationally expensive as well as bandwidth expensive. Is there a way to run, say, like I could run my Pokt node on one machine and point to a bunch of different machines? Because the likelihood of running all of the stuff on one machine is not reasonable.
Yeah, yes, that's exactly how it works. Our plugin system is actually an interface that allows you to connect, for example, to a load balancer where you're running 20 Geth instances in 20 different machines, and it actually load balances. Or you can actually do very cool stuff where you can say, okay, all the read requests go to this load balancer and all the write requests go to this other load balancer, because we're thinking about the infrastructure provider when we're designing all this. We want people to have all the options that they can to mix and match architectural components to the best to the most flexibility that we can allow in terms of security, to actually go ahead and configure your nodes however you see fit. Some people are gonna probably find out that having taller machines, which means bigger, more capable machines, is probably going to be a bad approach versus having a 40 different nodes running different services and using a load balancer to coordinate it all. So yeah, we're trying to keep it as flexible as possible.
So it seems like this is the tooling. You're trying to make tooling for people to become their own generalized infura for other people, and then that's a more like the infrastructure side of using your software or using your service or the platform. The other side would be to just make it easy for DApp developers to say, I need information from this network. Go get it for me, Pocket. Is that like a reasonable, like the two sides of what's going on in this platform?
Exactly. You can think of it like a two-sided marketplace, just like that. It's a developer-driven platform. So, if developers are using Pocket, there will be a market of nodes willing to spin up to service those developers.
And like you mentioned that the token is minted, it's an inflationary market. Can we talk about the kind of economics around this token, how it works, what its like supply is, how things get moved? Like I'm trying to see there needs to be a value. Like I need to make money as a infrastructure provider serving requests to a bunch of people. If there's like if the value associated with or the cost associated with running this infrastructure and serving information is much, much, much larger than the value I'm getting on the Pocket network, then it doesn't. Why would I keep using it? And like how does the economics play into there?
Yeah, great question. And that's so So I think one of the most unique things about Pocket is our economic model, because there's a bunch of knobs that can be turned, and part of launching this is testing this and seeing how those knobs affect the liquidity of the token and the price of the token, things like that. But in the end, there's three main economic mechanisms that are in Pocket. There's staking, there's minting, and there's burning. The interesting thing about Pocket is we don't have a static mint like Ethereum does or Bitcoin does or most blockchains do. Our mint is actually based on per API request. So as Pocket gets more popular, more Pocket will be inflated or more Pocket will be created out of thin air, right? That being said, if Pocket's getting more popular, more people have to stake our token to use the network. So there's kind of a balancing act there at equilibrium, over the course of time. Another thing that's interesting is that normal transactions on Pocket, the fees are completely burned. So what we think at maturity of the protocol, which we don't know when it's going to be, but we think that the profit that a node is going to make in the end is going to be the delta between how much Pocket was burned and how much extra Pocket was staked during a given amount of time. There are three main burning mechanisms in the protocol. One is the fees. So every time I do a normal Pocket transaction, that gets burned. Obviously, if you're a bad actor, your tokens get burned. And the third part is we have a DAO directly inspired from Dash, where to make a proposal, you have to burn some Pocket to actually submit your proposal. So between those mechanisms and the growth of staking, we believe that will actually, at maturity, keep the total supply, let's say, of the tokens relatively even, or maybe even hopefully deflationary.
Done any modeling on that? Like I'm trying to like picture that and like what it looks like in the end and possible ways of like manipulating this type of thing. And what the cost would be for staking node infrastructure. If it gets too costly to actually stake and participate, then you have no other way to get tokens into the system to kind of
correct. So ours we've taken a bit of learning from LivePeer, so it's a dynamic staking model. So whereas like with Dash, they've capped out at like 2,500 master nodes or something like that because of the price of Dash. It's growing slowly. Ours is a dynamic stake. So that number as a developer, for example, if I have to stake $2 worth of Pocket and then the price goes up, triples the next day. Well, I don't want to have to stake $6 worth of Pocket for the same amount of work, right? So there's a dynamic staking mechanism there that actually is based on how much a Pocket is staked and how much a Pocket is circulating. So this whole economics thing, this is what we're really, really deeply working on right now. Tracy, she's working with us. She's done a ton of modeling, and we're really working through the best way to go about this and the best way to execute on this plan, because it is a different model because the way it's going to grow, it's going to actually grow based on the usage of the network, right? So part of that is making it expensive for me to self-deal, for example, things like that. So if I am a client and I have a node, well, if I'm just serving myself API requests, well, I'm needlessly inflating the network, and that's a problem. So we've thought through a lot of these problems, and it's hard to test it until it's live. So we can't wait to actually test our models and our theories when the protocol is actually live, right?
Mm-hmm.
Or at least in test net.
Yeah, I got it. Go ahead, Luis.
No, I was gonna say that we're gonna test in testnet.
Yeah.
no when it's live. But yeah, Michael, that's a very important point to keep for the record.
Yeah, that's actually, yeah, I understand the correction there, and I see this. So in the process of creating this, so your platform grows and gains its value based on the service requests. It's like basically the traffic it gets from various networks. So you actually see your success is not relegated to a specific network. In fact, it gives a lot of usage statistics across all of blockchain, depending on how much your system is being used, on what decentralized networks node infrastructure is actually in most demand across the board, assuming that people are all using Pocket, if I have to say. Have you considered what type of metadata you leak for the users? So I'm trying to think of looking at this from a forensic analysis perspective of the type of data that flows across your network and what I could gain from that, as well as just data analytics in general, how I could extract usable, insightful information from the data flowing across the network and the usage statistics. Have y'all thought about that at all?
Sure, we've thought it about quite considerably, and in every step of the design, we're always asking ourselves how we need to use the least amount of data to get the most amount of reward out of that data. And basically, from a developer point of view, we're creating this whole authentication system based around policies, so to allow developers to pick and choose which models benefits their app the most in terms of user authentication. Because we are striving to a model where if I want to create an app that has no backend, I'm a developer and I don't want to host any infrastructure. I just want my users to connect to this website or download the app. They need to be able to go ahead and do that. That's from the developer point of view. So from a developer standpoint, they will create developer IDs, which is a subset of metadata, and every user install, we're calling it a user install, but if you go to the web, it's going to be every user that is using the app, every instance of the app, will actually require to have an account, a Pocket account in the background without the user doesn't have to know about it. And they use that account to sign the transaction. So in that particular sense, we're not doing any KYC, we're not doing any, we don't need to reveal any data. And from the node standpoint, the only piece of information that we can't get away from revealing is where is the node endpoint actually is. Like what's that domain or what's that IP address that you need to connect to. Because in the end, it's not actually a decentralized DNS where you provide a domain name and you don't even know what the IP address behind that is. You actually need to know where to connect to, and that's part of the whole coordination layer system. So that's the only piece of information that the nodes leak, if you may, where whenever they stake, they need to actually specify the endpoint to which clients will connect to service, to get service. So I hope that answers your question. In terms of the blockchain nodes, if you think about Geth, for example, now if most of the audience is Ethereum friendly, in Geth you have boot nodes because it uses Kademlia, the Kademlia algorithm for peer-to-peer connectivity, and you need boot nodes that actually help you build a routing table. Those boot nodes expose the IP address or domain that you use to connect to. And then in your peer list, you have all the IP addresses that the nodes that you're connected with have, so you can actually send and receive data. So we believe that with this minimal amount of information, and of course, we will have guidelines, we will have better practices for our node operators to actually go ahead and keep their nodes safe, even if they're exposing a public-facing interface. But that's a standard web security, like you need to mitigate DDoS, you need to mitigate all sorts of scanning into your network and all those sorts of things. So that's pretty standard.
So just to let you know, I sidebarred Corey for a little bit. I'll be frank, I wasn't getting it at first. I heard your explanations, and one of the reasons why I wasn't quite grasping it is because I kept hearing Infura. And it doesn't sound like that's a strong enough analogy to what you're doing, because Infura basically takes... I'm sorry if I'm jumping in and you just, I'm derailing this, but I have been trying to figure this out genuinely. I've been looking over your white paper. I've been trying to dig deep in this. And I'm like, Corey, I don't get it. If it's like an Infura, Infura batches things and uses Ethereum as the main truth mechanism for the entire decentralized application that I'm using. So if these guys are trying to do something, I kept hearing decentralized Infura, then basically I would expect at some point I would send a transaction, it would get resolved on Ethereum. Now, Corey, yeah, you're shaking your head. Corey's corrected me on this, and I think this is probably one of the main points of confusion I personally had, and I cannot see myself being the only person. Is when you bring up Infura, you see one model of doing things, which is basically this centralized service which you dump your stuff into, and it will put it in a blockchain for you in a batch process, and that's not what this is at all. It's its own resolution layer. You have your own blockchain, which is something that also threw me, but I got and I understood, and I figured why that would be useful when it comes to cross blockchain communication. But you're not acting you're actually the app layer. You're the transaction layer. You are the resolution layer. You are your own resolution layer, meaning that everything resolves to your token, and then you can exchange that token for value on the other networks. Is that correct? Did I finally get it?
I didn't. So.
Go ahead.
I don't think so.
When you say,
I'm still not getting it. Help me out here.
When you say everything resolves to our token, like our token, you could think of is the value of all the validated API requests that all the hundreds or thousands of mini Infuras are servicing in our Pocket network, right? So everyone's doing a bunch of work servicing a bunch of dApps as kind of like a middleware layer, if you will. But it's its own protocol and sits next to Ethereum, sits next to Bitcoin, everything like that. All these API requests and doing all this work. And the result of that is the minting of our token. So you could say that, yes, the token's value or the token's work to have been minted is the result of the work done in the network directly, in that sense. Hopefully, does that clear anything for you?
But maybe this might be easy to elucidate this.
I'm having is, hold on, let me get this thought out. The fundamental problem I'm having is I want to use Ethereum, right? How, as a dApp developer, am I using your network to facilitate that? Okay, I want to use Litecoin.
You got okay, that's the question.
Yeah.
I think it would be easy to elucidate how this works by going through the life cycle of the request answer process as well as the payout from that service.
Sure. If I may illustrate the Infura life cycle and then ours, maybe it will create the best analogy. Because here's the thing: if I'm a dApp developer and I want to connect to Ethereum, I need to run my own Geth or parity node, right? We're clear up until that point. So basically, most dApp developers don't want to deal with that because Geth can be quite resource consuming. It can be unstable at times, like where it's like my Geth instance stops syncing and all that. And I don't want to deal with that. I just want people to send cats to each other over the network, right? So what happens? I submit a request from my dApp into a Geth node that it's alive and that it's synced up, and I'm able to send my transaction to that node, and that node magically will propagate that transaction all the way into the blockchain, and it's going to be confirmed. I'm going to go into Etherscan, and I'm going to be able to see by my transaction hash that my transaction is confirmed. Until that point, that's the first life cycle. So where Infura goes in, it's hosting that get node. I don't want to deal with that. Like I'm a developer. I'm a iOS.
Oh, I got it.
You see? So I only host my app in my server.
Yeah, that brings up the AWS analogy that Michael brought up earlier, and now it's all starting to click. I'm sorry that took me so long. So basically, it's a rental service sort of for host nodes, like main full nodes. Okay, I get that now. Now my question is, that doesn't solve the throughput problem, does it? Technically, because you still have to manage the whole like. I need to get my cats through and there's too many requests, right? So how do you solve that?
True that. So there's two sides to that coin. Like there are two angles. So first, yeah, we're not a layer 2 solution that is trying to solve the scalability problem. But on the other side of that coin, there are things infrastructurally speaking that can ease up the UX of apps using Pokt versus using a raw connector or using just Infura. So for example, one of those things could be, since you know for a fact that the node that you're sending your transaction to is economically incentivized to have the transaction be put on the blockchain, we are thinking that there will be a secondary market for a kind of an asynchronous service where I submit my transaction and I get some sort of ticket, like if you will get like for waiting in line, right? You get a ticket, and now you know that there's a node that is economically incentivized to put my transaction on the blockchain, and I can use my ticket to query the state of that transaction. So that way I can build UX around that. I can help facilitate my users through that asynchronicity of blockchain design and product design. Now, that said, that's not a core part of our value proposition. What we're proposing is actually highly available nodes that are willing to take on your requests. Every network's limits and throughput capacity, it's not something that because we're not asking those networks to modify their clients. We're just connecting to them.
Gotcha. So this takes care of a lot of the issues that also people typically deal with, like keeping their nodes up to date or whatever. And like you don't have to worry about that anymore. You can check version for them. You can check, this fork happened. Your node that you're subscribed to decided to hop on this side. You don't want to be on that side. It'll automatically put your stuff to the correct type of. So let's just say ETC versus Ethereum split, for example. Like you would actually go, okay, I want Ethereum, but I don't want to jump on ETC, whereas other people might go, I'm going full ETC. Now the dApp developers are driving the conversation a little more, and the demand for the marketplace is driven by the developers of decentralized applications rather than the people who are simply hosting the nodes themselves, which to me is actually extremely interesting because, like the BCH and whatnot, it's showing that hash power doesn't necessarily drive the conversation, that developers are driving the conversation, and that people using the coins are driving the conversation. So the end user, whether they be a developer or somebody just exchanging assets, are the ones who are actually driving the value. That is automatically going to be taken care of through your network. So my dApp doesn't actually have to care. It just goes where the users are going, and that makes it a lot simpler for me as somebody who just wants to develop a dApp and get it out, to not have to worry about that kind of stuff. Cool. Okay, I think I get it now.
That guarantee is based on people using Pokt. So like the ability for someone to say, all right, send me this information. I don't care how I do node discovery to find it, is taken up through Pokt, but that requires people on Pokt running that node infrastructure to be servicing those requests. How do you get the level of adoption required to have good service availability while you grow?
Great question. So we've got an entire plan right now to have as many nodes as possible running Pocket by the time we launch the protocol. We have, so if you go on our GitHub, you can see that we've built an Ethereum endpoint, so ethereum.pocket.network. We've just finished our Aeon endpoint, and we've also done an RChain endpoint, for example, and we're working, another company, they're actually building out a one-chain plugin, right? So what we've done is we've open sourced our entire AWS config to make it as easy as possible for people to actually spin up their own infrastructure. And another piece of this is through running this infrastructure, we're actually going to be doing a simple DAO with an airdrop on Ethereum. So a good chunk of our tokens are going to be there, and people who are participating in the as a node in Pocket will have a vote as to what happened. Exactly, like think of it just like a dash DAO. We'll have a vote as to what happens with those funds when proposals come in to build, some interest in the app, or someone wants to be another node or something like that. So we've already talked to 3 companies who actually want to participate as a node with Pocket, and frankly, our stuff is all there for anyone to run. So our goal is to have as many people running this as possible, so that by the time the protocol is live, they can just plug in and actually start participating in the network. So we are doing our own KYC in that sense, where we're working with companies who we think are reputable, who are who are talented, technically strong, who we think can really do this kind of a heavy technical lifting, right? Because this isn't necessarily the easiest thing in the world to do. Yeah. That being said, we are trying to make it as easy as possible for kind of like a one-click, hey, I'm going to run my own AWS with my own endpoint kind of a thing as well. So we are trying to make it as easy as possible, but yeah.
And if I may expand on what Michael said, Michael covered the pre-bootstrap and the initial launch of the network, but in the future, we're developing a process where the market is going to be able to vote on which networks are accepted and which networks are validated. Because me as a service node, I can go ahead and spin whatever network I want and advertise that in the network. And if a client wants to connect, if there are no parties to pay those tests, I don't get paid. So there will be a whole process to accept that network as a new network to support, and that's all going to be community driven.
So that leads me to my next question. So it sounds like you have a governance model kind of built into this. It's got an election process. It sounds like a DAO. So that drives me right to the consensus mechanism. You say you're proof of stake, but there's no solid proof of stake that's just like general and public and open at the moment. The ones I've seen that are successful are delegated proof of stake. Is that what you're running?
We still are experimenting with different knobs, as Michael said, but as a general concept, we are running proof of stake, but all the finalized details are not out in the public yet. So we can't officially comment to that, because we're looking at different models on how to do it.
Well, you can tell us a little bit more about what models you're looking at and why, and some of the pros and cons you're seeing, because I think our developer core would really like to hear what some of the results of your experimentation on that have been.
For sure. So there are two. When we say proof of stake, we're actually talking about 2 things at the same time. So one thing is what we mentioned before is the blockchain layer, keeping the blockchain spam free, having transactions being put on the blockchain safely and securely, and the whole economic of that model is basically I will stake an amount of POKT, and I will actually participate in the consensus of which block gets written to the chain. That's one side of the argument. The other side of the argument is the proof of stake for the validators and the service nodes and the clients. So the clients will also need to stake, but we're basically calling another stake category. When you stake to be a node, that's going to have its own transaction type that is going to be node stake. I'm not saying that's going to be the official name, but just to simplify it. It's going to be a sort of node stake where I input enough metadata to qualify me as a node. And then the blockchain layer is going to check that, and it's going to vote on whether or not that transaction is valid, and you're officially approved as a node. So that part of the proof of stake consensus actually is validated by our federated node system. So for a node to become federated, they will need to become a service node first and work enough to earn a reputation. We are using a reputation system. We're calling it karma for now. And you accrue karma by servicing the network enough. When you reach a certain amount of karma and you, on top of that, increase your stake into the network, you're going to be able to become a validator. There's of course the possibility that we may end up having a DAO step there, so we can actually let the community decide who becomes a validator of the network. So that part of the consensus is actually driven by that process.
Gotcha. And so to be clear, there are certain vulnerabilities, I'm going to call it, in your model. But the idea is that by exercising the power that having too many validators under your control for whatever reason to manipulate transactions would devalue the very token that you're investing in. Now, of course, that itself means that your value stored in the network has to outweigh the value gained from gaming the network, meaning that if you happen to have a bunch of validators that you own and you are trying to squash a competitor's transactions from getting through, you would basically, the preferable situation is that the amount of stake required to do that would outweigh the cost of that, would outweigh, squashing the competitor in some way. Is that correct assumption from what I'm understanding on the economics of this?
Yeah, that's one of the key indicators that we're using when designing these economic policies, because that's what they are. What we're trying to do is nudge the behavior of every actor in the right direction. So we incentivize people to behave the best as possible, or behave good, right? Because sometimes it's not as binary. When you're talking economics, it's not as binary as if you're a good citizen of the network or if you're a bad citizen. Sometimes there's a spectrum, and we're trying to take all those things into consideration to operate in the least margin of error possible.
All right. So when can we expect a testnet?
We're shooting for Q4 2019.
Okay,
but
cool.
As you know, software development, we're the worst. Like the human beings are the worst at estimating time.
Yeah, this technology is not easy. Setting hard deadlines on making sure it works properly is shooting yourself in the foot in a lot of cases. So, but it's nice to know when you can start saying anything. How do people get in touch with you and start interacting with you to help with build this process out?
Go to our website. We've got some open research forums that we put literally all our thoughts in, inspired by ETH research. So feel free to check that out. Obviously, our GitHub has got a ton of activity and a ton of repos. And you can definitely follow us on Twitter at POKT Network as well. And our Slack, we're pretty active on our Slack too. So I would say those are the primary. I would say Slack and our research forums are the two primary, and GitHub, of course, are the two primary ways to get a hold of us.
Nice. And as always, is there anything that we should have asked you or you hoped we asked you that we didn't get around to?
You can see a full working version of our stack. We released an app called the Nano Quest, actually, a few months ago. We built it at ETH Buenos Aires. I don't know how long ago that was, but me, Luis, and Pavel went over there and hacked there, and we built this fun app. It's like the Nano Quest, and it's like Pokemon Go and geocaching. So you find these augmented reality bananas, and they return to you some ERC 721s for completing the quest. And it's a fun, silly app, but it kind of shows the power of our technology, and we actually open source that entire app. So you can actually see, as an iOS developer, it's fun to create wallet, to create a wallet, right? So we've tried to make it as easy as possible for people to build using Pocket.
Nice.
Awesome. Cool. Thanks, guys. I look forward to seeing seeing some dApps built on this. I can't wait to play with the test network. Sucks it's so far out. I'd like to get my hands on it now, but that's definitely cool.
Yeah. Thank you. Appreciate it.
All right, that about wraps it up. Thanks for coming on the show, guys.
Thanks, guys.
Thanks for having us.
Thanks.
Appreciate it.